theater, please welcome co-founder of Dagger.io, Solomon Hykes.
Hello, everyone. Hi, my name's Solomon. I'm the co-founder of Dagger, and I'm going to talk to you about pain, specifically developer pain, the pain of automating all your workflows, all the workflows around your software development project. So, you got to build, you got to test, you got to lint, you got to sign your code, you got to deploy. There's always a new best practice or workflow to run. And so developers spend too much time on that instead on developing. So what do? We write scripts. And as we add scripts to keep up with all these workflows and tasks we need to run, we leave a trail of artisanal scripts behind us. And those scripts are just frozen in time. They do the job, but then they don't really evolve. And as the team grows, as the project grows, the script grows. And the scripts start accumulating technical debt. And that introduces problems. You can't test them. They start breaking randomly. You don't understand how they work. The person who wrote them 3 years ago is gone. And the larger the project, the more pain the team experiences because of those scripts. You can't collaborate, reuse them, combine them. So what do? Well, eventually, we just bite the bullet and start working on the platform. So the platform, is what will replace those terrible artisanal scripts with robust, scalable, modular software, a place that everyone in the organization can build on top of and collaborate on. And the problem, though, with that platform is that adopting it is basically like a revolution. It's very, very disruptive. It takes a long time to build and adopt. You got to abandon your existing practices and just kind of learn something new, and then it doesn't work everywhere. And so you're kind of stuck in between a little bit of scripts, a little bit of a platform, and it's just a whole year of productivity out the window, down the drain. Anyway. But we have a solution to that as an industry, which is to bring in consultants to tell you that you adopted the wrong platform. But there's this new platform that will be completely different because this time it's going to kill all the other platforms and it's just going to be perfect. And all the scripts will be gone and it'll just be great. And of course, the cycle continues. So that's kind of the loop we're stuck in now. And we think there's a better way. So at Dagger, we're trying to work to introduce a new approach to this problem, which we call incremental revolution. And the idea is to get the best of both worlds. Everyone keeps their scripts, whatever tools and workflows they're comfortable with. But over time, as the scripts grow, you take that logic out of the script, the automation logic that's interesting, that others want to reuse, that you want to compose with, test, scale, and you move it out of the script and you move it into an API. And then all those scripts gradually become clients to that API. And over time, your API grows, and the collaboration happens on the API instead of the scripts. And one day you realize, oh, I have an internal platform now. It's this API. So that's what we're trying to make happen. It's great in theory, but in practice, it's got a few problems. First, you got to find a way to take that automation logic out of scripts written in many different languages. Bash, JavaScript, Python, Go, Java, Ruby, whatever, and run them in a sort of unified way. If only we had some sort of technology that allowed running code from lots of different languages with a unified runtime and unified operational model. Of course, I'm talking about containers. And the second problem is that you need an API design that's modular and composable enough to actually allow for these pipelines to be added over time so that the API can actually grow and expand and still allow collaboration and scale. Otherwise, you just moved the technical debt from the scripts to the API and you have the same problem. So we've written a prototype at Dagger to try and solve that problem. And the way it works is we call it Project Cloak. I think there's a little link here. Yeah, so you can ask for early access. It's really not finished. I don't know if we should be showing it, but we're going to show it. And so it's basically a new container engine. And I know it's another one of those. But that container engine is designed to be embedded in your code, so in your scripts, and controlled by your code through an API, a GraphQL API, that's what we use, so that you can easily instrument your pipelines by running them in containers. And then over time, you can start extending that API and sort of taking over that container engine so that it becomes your very own custom automation API. So that's what we're going to show. If you're okay with a live demo, they may or may not work. Is that okay? All right. Okay. Let's see. I'm probably going to go over time, as I always do. So this is our little test project. It's a to-do app. It's a little JavaScript app. I'm a JavaScript developer now. And I heard about this Project Cloak thing. And I'm going to try writing a little deployment script with it. So the way I usually write scripts is I have this package.json file. Can you all see? No, you can't see anything, huh? I am unlocked. Things are happening on my screen. Help. Hold on. Let me unplug and replug. Roop, roop. Well, I don't have a live feed, so I could just pretend you're seeing it. Oh, no, it's not Wi-Fi. It's Sorry? Oh. Well, whatever I see on my screen, I can't see here. Okay, let me just describe it for you while the setup is being worked on. So basically, you add our SDK, our JavaScript SDK, into your project. So if you know JavaScript, you know npm, package.json. So you use those tools. Then you just write. Mosquito attacking me. All right. I'm being attacked by a mosquito, and my screen doesn't work. That's all right. So you add the SDK to your JavaScript project, and then you just write a regular JavaScript npm script in JavaScript the way you usually would, except instead of actually doing the difficult work of, in this case, orchestrating your build, then taking the result of your build, plugging it into the deployment tool to, say, Netlify or Vercel or Render, whatever hosting provider you choose. You can just write the little API call to Cloak in JavaScript to do that. So your script becomes, instead of 200 lines of custom automation logic that only works here and nowhere else, it's 30 lines of custom code, and then another 50 lines maybe of clean, reusable API calls. The nice thing about that is that another team, say the backend team working in Go, they don't want to use npm scripts, they don't want to use JavaScript, but they need to deploy my front end exactly the way I like to deploy it, and they want to integrate that deployment pipeline into their own broader pipeline. Maybe they want to deploy my front end plus their API and then connect them together. So the way they would usually do that is just write a script in their own favorite tool. Here I was going to show a nice tool called Mage. For anyone who's a Go fan, Mage is really nice. It's a replacement for Make, except you write Go. Anyway, this hypothetical backend team wants to use Mage, but they want to deploy my front end, and my logic is written in this little npm script. So usually that's where the technical debt would begin, because now you have a script written in Go that needs to somehow integrate with another script written in JavaScript, and now you have a mess of tools that you need to install and just kind of, or script calling a script, and that gets really messy really quickly, because a third team is going to show up and they're going to want to integrate with the Go script and the JavaScript, and you get a mess. So instead, what you do is you take your existing automation logic, that script, and you turn it into an API extension for Cloak. And so literally our engine will just load your code, and all of a sudden, in addition to the core API that's available, to run a container, download an image, pull a Git repository, all those primitives, now all of a sudden you've got a custom app deployment action that you can add and compose with everything else. And so this Go team now can write a script of their own, another 30 lines, where they just load your extension, and they make an API call to that, and it's going to, under the hood, trigger my automation pipeline written in JavaScript. They don't need to know what language I wrote it in. They'll just see it kind of run, because it's all backed by an underlying container engine. You get all the benefits of that. So it works the same on every machine. You get nice caching and portability properties. You can farm it out to a giant machine on a server somewhere to make it faster. You can run it from CI or from development. So basically all the benefits of containerizing your app that we're very familiar with now, you get for the pipelines that are going to ship your app. Turns out it translates really well. And then on top of that, you get all the benefits of GraphQL. So for those of you who don't know what GraphQL is, it's one of the fastest growing ecosystem in the API development world. So it's a way to expose a service as a data-driven API that can be explored in a very powerful modular way. So instead of saying, here's action 1 and action 2, and that's all you can do with my API, you can just expose your data. And then clients can just explore it any way they want. Here, the data we're exploring is the entirety of the available automation steps available to you and your team. So really what you're exposing is an API for your supply chain. You're exposing your supply chain as a highly modular, highly explorable API that an entire ecosystem of tools, libraries, language integrations can just plug into, and it just works. So one thing that we've noticed when we've shown a demo that you'll have to come see it some other time, I think, is that web engineers, front-end engineers in particular, they see this GraphQL API, they see how you can extend it and write clients or extensions for it, and use all of the tools that they're familiar with. For example, there's a really cool interactive sandbox for GraphQL where you can just sort of browse the documentation, sort of figure out what's available, and write queries on the fly, see the results. We have that out of the box with Project Cloak. And so there is kind of a magical moment where engineers that are not familiar with DevOps or cloud engineering, they're working on a web app, they're doing front-end work, but they know JavaScript, they know GraphQL, and they see it, they say, wow, I can kind of take charge of my own automation here, and it's sort of a path towards the wonderful world of DevOps for a whole new community of engineers. So that's pretty fun. So yeah, the end result of all that is that you got a front-end team that's still running NPM scripts the way they like it. You've got a back-end team running automation scripts the way they like it. They don't have to learn each other's tools or language, but they can still reuse each other's automation pipelines, which means they can participate and collaborate through a shared API in their common supply chain. And then someone else can come in from anywhere in the organization and do the same thing, build on top of those building blocks, add their own. So we're starting to see, oh, well, look at that. We're starting to see machine learning teams join the fun and kind of add their piece to the pipelines. So I guess it's going to be more abstract and theoretical than I expected. But if you're seeing this and we don't have time to finish the demo, because there's no time we're going to finish it, just go to dagger.io/cloak, sign up for early access, and we'll give you a demo over Zoom. Or here, come see me afterwards. All right. OK. All right, so I'll skim through to prove that what I said is actually true. It works. So OK, this is our little JavaScript app. The NPM scripts I was talking about are here. So the way I would add a script to say deploy, the usual way as a JavaScript dev is I would do something like this. You can actually see my screen now, right? Okay. Just checking. Just say, let's see, I'll deploy, and you would want to write a script somewhere else and run it, something like that. I am told that is how things are done in JavaScript world. So then I would just create a, this is me adopting Project Cloak for the first time. Scripts, deploy, and then create a file. Here's a little skeleton here. So I import the SDK, start the Cloak engine, and I make API calls to it. And here, what I want to do in this case is I want to get the source code for my project somehow. Then I want to install its dependencies, build it. This is my usual build process. And then I would deploy here to Netlify, which is one possible hosting provider. So I need to make these API calls, but what kind of calls do I make? Well, I run Cloak dev, and it's going to load up my project and give me this. So this is a standard GraphQL sandbox, very common for in the web development world. So here I have interactive docs, and I can see the core API of Cloak, this container engine, and I can see what I can do. So I can, pull a container image, I can execute a command, I can read a file, etc., and then I can just kind of experiment here. So I can say, let's see, core image. Let's pull a container image, and then from that image, let's execute a command. Well, we'll just see where we are here. And then I want to see the standard output of that command. So then it's going to run stuff in the background. This looks a lot like an output of a Docker build. It's because it uses the same tech under the hood. It's all build kit. And so there you go. You can see we're running in what looks like the Docker for Mac VM. Maybe I want to install a package. So I'm basically creating my own Docker file, but with API queries, and then I will orchestrate these queries in code, in the language of my choice. Let's install Yarn, since that's what I want to do. Anyway, I'm not going to do the whole thing. You can see it's running again. I get caching. That cache could be shared with my team, so as we all do run the same pipelines, it gets faster. Okay, you can see it's installing. Okay, so basically the flow would be I interact with these little docs, and then I just copy paste that query in here. Just add. Oh, let me quit that. Just add a little bit of JavaScript here, client request, blah blah blah, and then paste it here and keep going. And then I can take the output of this query, plug into this query here, and just keep going. So that's the general idea. Let me just do a time check here because we're kind of off. Should I just keep going? All right, I'll keep going. I'm doing the short version since we went over time. The result here is, let's say an hour or two later. Now I have, something that looks like this. Okay, so this is a script that I want my team to use to deploy a test version of their site. So, they need to get an API token. This is all my code, actually. This has nothing to do with Cloak. This part here is just me presenting a little interface to the user, get the token, get the site name, print little messages. Okay, now I start the Cloak engine, and I'm going to load the API token into a secret. So Cloak has a built-in secrets API to do all that stuff securely. And here, I have this fancy GraphQL query. Again, if you are confused by this, just know that it's a very standard query language that a lot of front-end engineers know, and a lot of tools are compatible with, which is the point. So here I'm saying, okay, load the contents of the working directory on the host, so on my machine. Then pass that into a Yarn script, so this is the JavaScript build tool, and take the result of that and pass it into a Netlify deploy operation. And here's the token and the site name that I got earlier. So I'm just kind of passing the inputs it needs, and then I'm going to print the result to the user. So first, well, yeah, if you're familiar, if you looked at the code before, you maybe have a question here, and what the hell is going on here? Let me get to that in a second. The team would then just say yarn deploy. So they don't have to learn yet another tool. They don't have to learn yet another config format or language. As far as they know, someone on the team finally wrote the deploy script. They finally got around to it. And wow, it's pretty fast. Wow, because it's a lot of caching. And look at that, it's deployed. So let's see if it actually worked. Oh, OK, I deployed an app. So just a quick note here. These are API calls, right? That's a GraphQL query. So does this mean, so there's a yarn thing and a netlify thing. Does that mean the project Cloak API just has built-in support for specifically yarn and netlify? No, these are extensions. So what I did is I have a little config file here, and I loaded 2 dependencies. I just sort of told Cloak, OK, go fetch this and just load it into the API. You can see there's a yarn extension and netlify extension. You can get those from anywhere. Anyone can develop them. And so basically, what happened is it added more data. It expanded what the Cloak API could do. So now, if I go into the same sandbox as before, it's just loading the extensions. You can see it's talking about loading extensions here. Now, let me just reload this. Now, the docs includes netlify, deploy, yarn, build. So I'm just kind of expanding the capabilities of my little API in real time, right? Both with someone else's extension, or now, final step, because I don't want to take too much extra time, my own extension. So now this Go team I was talking about before, they want to use this. They want to deploy my front end on demand. But they don't want to install yarn on their machine. Yuck, that would be JavaScript things on their pristine, pure Go environment. So instead, I took that code that I showed you, that JavaScript code, actually, and I slightly modified it, and I created an extension. So this here, you can see the core logic is the same, but it's wrapped in a little bit of a extra logic here. And I have to write this little GraphQL schema to tell the Cloak engine, this is what I would like to add. There's a to-do app type now, and I want to deploy, and these are my inputs. I take a file system object, so basically a directory, a token, a site name, and then boom, I'll take care of the rest. And here's my implementation. So if you saw in the docs, you noticed maybe there was a to-do app entry as well. So my extension was also loaded. So now anyone can just, through the API, consume this little piece of automation, this pipeline that I wrote earlier, without knowing anything about how I wrote it. They just kind of, oh, OK, let's look at how it works, and then someone did this, the API team, and then I'm finished, I promise, because I feel bad that I'm taking too much time. They used a Mage file. They wrote a Mage file. I talked about Mage before. This is what it is. It has a cute little logo and everything. Oh, maybe that was a bridge too far. Oh, look at that. No internet. OK. Oh, that's OK. Go check it out. It's great. You basically write a Go function, and you put this little thing on top, and then you can just use this as a makefile. So you can just type Mage deploy. So here you can see same logic as before, but in Go, they did a little bit of UI of their own. They decide how they get the token, how they get the site, what message they print, but then you can see they start the Cloak engine, and then they load the secret, like I did before, because they need to pass me that token. They get their own working directory, core.workdir, and then they just call to-do app.deploy. That's my code. That's my script, my extension. And the nice thing here is you notice there's no GraphQL queries here, because what Cloak does also, our SDKs will generate a nice client library for you to interact with the core Cloak API and whatever extensions you have. So if I need netlify and yarn, or in this case, if I need an internal, I need the front-end team's to-do app deploy capability, I have that as a nice Go library. So it's just, this is the cleanest possible Go developer experience you could have. So this is it, that the backend team can now they can say mage deploy, and they can deploy the same thing I deployed. Or let's see, I'll just finish with this. I'm going to deploy a new one. VMware Explorer. It really works. That's maybe too long. It works. Okay, so you can see it's going too fast, but it's basically installing Yarn, installing the JavaScript tooling in containers, and then running the JavaScript tooling to build the app, and then passing that into the Netlify client in a container, and then uploading it. You can see the Netlify API saying, OK, I'm processing it. It's almost ready. And why didn't it work? Oh, there it is. It printed the URL here. And look at that. I got my own instance of the same code. So we got two teams collaborating on a common API and building out a common platform to automate a common supply chain without at any time disrupting their workflows with having to learn anything new. And that's the point. That's what we call, again, incremental revolution. And it's a lot of fun. So that's it. Sorry for the technical issues. And if you want to see a live version of this demo, come see me later. Or you can go to dagger.io/cloak and join us online. Thank you. Hi again.
Well, good job handling that. That was fun stuff. Well, when we've been talking about this, we were talking last week about it, and to modify like a discussion that we had a little bit, it was well, to add some context, like I don't know, maybe I don't know if it's fair to say, but like y'all are trying to make the pipeline more programmable, kind of apply like application development ideas to a pipeline, and I wonder, being here at VMware Explore, I should make sure to say it the right way. Like, how would you explain what y'all are up to like an operations person who's like more, maybe not so steeped in the idea of like how would we make something programmable, but how do you kind of think it layers onto their mindset?
Yeah, I think is this a good? Okay, yeah, that's definitely what we're doing. I think. I mean, there's a big change going on, and the work of shipping software is getting so complicated that it needs to be automated. The bar is rising, it needs to be automated in a more and more sophisticated way.
Yeah.
To the point where a script here and there is no longer enough. You need to think of your supply chain, the supply chain of your software project as a software project of its own. So it's the code that ships your code, it's the robot that builds the robot, that kind of stuff. So, I mean, if you're involved in the operations of that supply chain in any way, whether it's all the way from, I guess, the racking the servers part, I think everyone kind of is on board with, okay, that's automated. But the next layer on top of that, it's got to be fully automated from the code is ready to go. Next version of the code is ready to, okay, it's online. Everything else, it needs to be automated as much as possible. So a lot of, there's a whole community, let's call it the DevOps community, the people helping developers ship more productively. That community is transforming into a developer community of its own.
Yeah, it's kind of like I was just discussing this, that there's a kind of a lack of a phrase for that at the moment. Like, I mean, the most recent thing that's kind of, you hear platform engineer a lot and people kind of using that term for it.
Yeah, that's definitely part of it.
Yeah, and so exactly who would own is always a weird word, but be in charge of that tool change is emerging, as they say.
Yeah, I mean, in our experience, I mean, we are drawn to pain. That's a weird thing to say, but you basically are, as a team, we just like to find painful problems and solve them within our area of
have a useful
competence.
Solution.
Right, and so that involves talking to people a lot and listening to their problems. Otherwise, you just randomly building stuff.
Right.
And so, one thing we ask is about that. Who's trying to do this, and where are they in the org? Like, how is it organized? And it's all over the place. Titles change.
Yeah.
Titles are different. Org charts are different. But there's always. I mean, there's a moment in the life cycle of a project, that where one person has to be dedicated full time to just helping everyone else ship.
Right.
And the title could be anything, really anything. DevOps engineer, CI/CD. Sometimes just you're the lead, and that's what you do, but you do it full time. So the label on the hat is, varies, but the hat is always there as soon as you reach a point where your project is growing.
Right. It's like there's often the accidental build person. Like they just happen to be the one
that's
that
how it
day
starts.
started doing the build.
You say yes one time, and then you get pulled into it.
Right.
But eventually, at the end of the road, I mean, you reach a point where you have this dilemma that we were talking about, where we got scripts, and that's what we need now, but we need a platform, sometime next year, and there's a huge gap, and it's really hard to bridge that gap, and it usually fails. Sometimes the failure gets hidden, but it's usually it's really painful. So yeah.
I was thinking about kind of the terms you use, like incremental revolution. And I also think about what I'm reminded of back from your earliest days at Docker, where what I really loved about Docker in its beginnings was how it served as a way to almost embody your philosophy about programming the internet. Like there's this capability that we all have. And there was a certain amount of, I think, minimalism in it too. And I think of Kelsey out here who's a real minimalist himself. And I'm curious how you're trying to embody that in what we're seeing today, in what you're building.
Yeah, it's a design. I think it's a design. It's a design problem. I mean, we like to make things really simple to use and get to the essence of it, but it's really hard. Personally, I'm attracted to it because it seems so effortless once it's done, but the process of getting there is just so painful, and each increment, each increment of simplicity, of extra simplicity, it just gets, it's like the in physics, the closer you get to the speed of light, the more energy you have to spend to get just a little bit closer. It's the same thing, like the closer you get to the perfectly simple design where there's everything you need and nothing else, the harder it gets to advance. So we went through that process with Docker, with some success, but with also some we stumbled along the way, and so we're starting over basically. So that's fun.
Interesting. And so you're starting over in some respects. So what did you learn then that you're thinking about developing in this incremental manner? So I could see how the incremental revolution kind of concept comes by trying to do things more and more simple, right? Trying to and there's a pain in that, right? Revolutions can be very painful, no matter if it's, happens, at its peaks and valleys, wherever that revolution is. So.
Yep. Well, I think one thing is, what did we learn, right? In that process? Yeah. Well, one thing that we kind of had our sights on in the early days with Docker, but I think didn't realize all the way. We ended up following another path, which is fine, but I think there's something really magical about platforms if you can build them right. And I think the term is really overused, obviously. When I think of a platform, I think of something that you write code for. Like an operating system is a platform. You know what I mean?
Yeah.
And so I think to solve this particular problem, you need to sort of somehow come up with a new platform so that this community of people we were talking about that are trying to automate the supply chain, DevOps, that community, they actually have a platform that they can write software for, and it's actually a proper platform. You can which means mostly you can reuse each other's work and trust that you can reuse each other's work safely. And we don't really have that. I mean, we tried with Docker, with Docker images, and then later with Docker Compose files, and it's kind of in the uncanny valley where it's almost it's almost code, and so the thing running it is almost a platform, but it's not quite.
Yeah, it piques my curiosity because here at the show, we're hearing a lot about platforms and platform engineering. And my colleague here, Michael Cote, knows a lot about this topic on platform engineering. I know he spent some time on this. But a lot of it comes down to all those tools, right? And then that whole tool chain. But a lot of it is process, isn't it? And a lot of it is workflow. And so how do you like settle, how do you settle process and workflow, with platforms? Because if you don't have that process and workflow, it's just a bag of tools.
Yeah, I mean, I think all those things like workflows, runbooks, whatever it is that you have to do to ship, as long as it's not software that you can hand to someone and say, run this, then you're not done, basically. And I think that's what's happening right now, like the whole software is eating the world. Like right now, software is eating the supply chain. So those workflows, those policies, they're going to be code, and that code's going to have to run somewhere. And right now, writing that code and getting it to run somewhere and everywhere it needs to run and collaborating on it, it's just a mess. It's like the early days of I don't know, the web platform, or early days of personal computing. If you're writing that software now, you're like a pioneer. You got to glue stuff together, and you got to know 50 technologies inside out, and you got to be an absolute expert. But hopefully 10 years from now, let's say, things move slower than I used to think they do. Hopefully that won't be the case. You won't need to be an expert in all these crazy tools and technologies to write, to say, here's our supply chain, here's our workflow for this part of our compliance problem, or whatever it is,
So to pull together a few things there. I mean, we were talking about making your pipelines programmable.
Yes.
And kind of like one of the things you were saying is a platform is a place you put code. And like what y'all are kind of putting together here is putting code into a pipeline. So that sort of makes a pipeline a platform to some extent. And so to that end, anytime a platform emerges, I always think of, there's two things. There's one, like, to anthropomorphize it, like the platform wants you to think some way, or it's easier to use if you think some way, like the model on top of it. And then also, even though it's extremely early, like you kind of find some best practices and worst practices along the way. So I don't know. I mean, I'm curious, like how does this platform want you to think about a build, and like what's the model in the head and the behavior?
Yeah, that's a really good point, because I mean, there's a cost to a new platform. Okay, I got to learn this new API and I got to write code for it. So I think there's a sweet spot where, to be useful, like to add value, it's got to bring some sort of new opinion on how you're supposed to do things. You got to structure it this way, and you'll see it'll be great, and we'll help you. But at the same time, there's got to be a path to doing that. And so, like, if you're too prescriptive, and then it restricts the flexibility that you need in a given area, then you're going to be less adopted because it's harder to use it. So the sweet spot here is that if your software supply chain is itself becoming software, and we're talking about, okay, what's the platform to run that? Well, everyone's software supply chain is different, but everyone's software supply chain kind of looks the same. It's a graph. You got nodes and you got lines between them. Specifically, it's a DAG. It's a graph where everything goes in a specific direction, and there's no cycles. That's what a DAG is. That's what we're called Dagger, by the way.
So how are you managing that underlying graph?
Well, so that's where we bake in an opinion. If you use the Cloak API or the Dagger API to encode your supply chain in software, your pipelines are going to be nodes in a graph. They're all interconnected in a graph. We have that opinion. We say, if you're encoding your supply chain in software, organize it like a graph, and here's a platform for doing that. And so that's the trick for adding value. We can have an opinion about how your supply chain is going to be shaped, because we know it's going to be a graph. Therefore, we can narrow down the focus of our platform on just that problem. So it doesn't, then what you're going to do is just swap out the nodes in your graph. I build with this tool. Well, my keys are in HashiCorp Vault. Well, I host on Kubernetes on this thing, whatever. You just swap it out. You're just reorganizing your graph, but it's still a graph. And if under the hood the API lets you just reuse someone else's components into your graph, and take a whole area of your graph and wrap it in a box and say, take all of that. That's one node in your mega graph. Yes. Then you have potentially an amazing level of collaboration and innovation, which is what's missing. So what's missing is like a platform that's actually capable of doing that in code, and it actually works. It's a design. Again, it's an engineering design problem.
Right.
The way Lego is an engineering and design problem, it boils down to the individual brick. You got to engineer it in a way that it's simple enough to snap together, but it actually like holds.
Yeah.
And you can stack it up, and you can break records in height with your super tower or something, and it still somehow works. That's an amazing feat of engineering. That's the hard part of what we're doing. Saying, okay, we're obsessing over tiny little details so that you can just stack up and up and up and up, and one day run a giant supply chain over it, and it works, and you can trust it.
Right.
That's what we're trying to do.
So it seems like, there's at least, I'm sure there's more like two ways of thinking that are going on here. One is that you should think of, whether you want to call it a build or a pipeline or a supply chain, it's always fun to come up with a phrase that the most fundamental thing you need to do is think of it as a graph full of nodes. And if your pipeline doesn't think that way, that's what it should do, right?
Right.
And then the second thing is basically and then you need to think about it as not so much configurable or scriptable, but programmable.
Right.
And you'll be coming in with a programmer's mindset, and then that brings you being able to reuse and share and swap things in and out, which is, again, much different than I think the majority of pipelines are thought of and gone through.
What's interesting is just finding a way to ease into it. We talk a lot about scripts because that's what exists today. So being able to embed something more powerful inside an existing script and kind of give you a way to gradually adopt this programming model on your own terms, you need that, otherwise it's really hard to adopt.
Difficult.
Yeah. That's why Docker files worked so well, because they met you where they didn't force you to become a better human being, to be worthy of using the tool. Just the tool, you do it this way. Okay, cool. Write this Docker file. It works.
Right.
I just got the sign that we got to wrap up, but maybe in conclusion, you can talk to us about how you're looking to build out the community platform. I know you built it initially on Q, the programming language.
Right.
What else are you doing now to help build it up?
So basically, this prototype we showed, we haven't launched it yet. It's not ready, but we're adding the support for doing this in any language. And Q is one of those languages, but it's going to be one of many, and we're going to open all of it. And hopefully, you'll see people reusing each other's components through this common API across any language. So you get an element of cross-language collaboration and code reuse that's very exciting.
We'll have to learn more about that another time.
All right, well, thanks. Yeah, it was
Thanks
fun
so
talking
much.
to you.
Yeah,
And thanks for the demo. You did a good job.
Thanks a
going
lot,
through the
Solomon.
motions.
Thanks.
Bye-bye.
Bye.